All right, welcome back to part 2. We're going to look at some slightly different types of trig equations here and get myself settled in the right spot. Okay, so here we go. Part 2. This one's a little bit quicker, I hope. All right, one other type of equation you might deal with is you just have to do a little bit of rearranging and use some algebra skills. That's what is going to throw the little wrench into here, and it shouldn't be too bad. So let's go ahead and take a look at what we've got this time. Root 3 tan x minus 1 is equal to 0. We're solving for tan x, so kind of isolate that piece and solve for that first. And when you do that, we add the 1, we divide by the root 3, and here we are, tan x is equal to a number. We're going to go ahead and look at the chart, do this reverse, think about it as an inverse. X is an inverse tangent of 1 over root 3. Rationalized would be okay too. However you cut it, x is equal to pi over 6. Again, like we saw in the previous set, tan x might also be positive in quadrant 3, so we have to consider the quadrant 3 angle whose reference is pi over 6. Here's the diagram. It's 7 pi over 6, and we're done. Next problem. 4 sine squared minus 1. Isolate the trig, add 1, divide by 4. It's squared, so we're going to take that square root. But we know that when we take the square root, we're going to get a plus or minus. Don't forget the plus or minus. So sine x is equal to plus or minus a half. When sine x is equal to just regular 1/2, that's pi over 6, right off of the reverse chart, inverse trig. Except now we can consider any sine of that, plus or minus. That occurs in all 4 quadrants. So all we're looking at here then is any angle whose reference is pi over 6 in any of the 4 quadrants. Kind of confusing here, but I tried to do some colors. In quadrant 2, here's my reference. Gives us an angle of 5 pi over 6. In quadrant 3, here's the reference. So the angle is 7 pi over 6. And finally in quadrant 4, and here's the reference, all the way around to 11 pi over 6. Including the original 4 answers, we're done. This is the last example here. 2 cosine squared minus cosine x minus 1. Seems like, what are we supposed to do? I suggest take cosine, because that's what we're solving for, replace it with a simpler variable. I call it p. We get 2p squared minus p minus 1. You should recognize this as hopefully factorable. It factors pretty simply and lets us solve for p. So p is negative half or p is 1. Well, in this case, get me out of the way here. P was cosine x, so cosine x is negative 1/2. We've worked this type of problem before. The reference angle for cosine being 1/2 is pi over 3. Cosine is negative in quadrants 2 and 3, so the quadrants 2 and 3 angles whose reference is pi over 3, again, we could always be drawing, here's my pi over 3 in quadrant 2, that gets me my first angle, 2 pi over 3. Same thing when you do the reference angle down here in quadrant 3, except now the angle is much bigger. There it is, 4 pi over 3. Meanwhile, p could also equal 1. Cosine is 1, and that occurs, max value for cosine, it only occurs once at pi over 2. 1, 2, 3 answers. And that's all I've got, but let me just say one last quick thing. We looked at 3 simpler examples. It is possible in problems like these that you might need to use an identity first. So you might need to use a double angle identity. You might need to use the cosine squared is 1 minus sine squared identity. So it's possible that you might have to use something like this to get it into a form that now we know what to do with. So there you go. And look at the optional problems if you want. Go and take a look there, and then we'll look for your graded work at the end of the week. Have a good week.